So let us come to the second paper for today's paper presentation, where we will talk about the Saez paper from 2001, using elasticities to derive optimal income tax rates. So the starting point of this paper is that there is also nowadays an ongoing discussion about the degree of progressivity of an income tax schedule when a government is caring about redistribution. Yeah, and it's clear that more progressivity, oh my God, this word. So more progressivity allows for redistribution, but in addition, it has efficiency costs because it distorts the behavior of individuals. And Saez is basically referring to the Millis paper and other papers which are building upon it, and concludes that the literature actually has limited implications for policy. In that, what the previous literature identified is that, the results had very few general properties. So the results that the papers derived were basically not of any relevance for people who wanted to do policy, because just saying that the marginal tax rate must be below between 0 and 1, or saying that at the top of the income distribution the marginal tax rate should be 0, is of almost no use for a policymaker. Yeah. So one issue was that the optimal tax schedules, which were derived in the previous literature, had very few general properties. And related to this was that the literature was mostly considered by theorists, so economic theorists, and there was little attempt to derive results. So little attempt was made to derive results which could be easily estimated or used in applied studies. So what are the results which are included in the paper of Saez? So first, it is shown that the optimal high income tax rates, so tax rates for individuals with high income, can be expressed using substitution and income effects, which you should know from an introductory microeconomics course, and the top-tailed thickness of the income distribution. So in addition, the first order conditions that we had in Merle's paper are expressed in terms of elasticity, and the key economic effects are identified. So SAS is basically able to identify what's relevant, so from in economic terms, in this first order conditions, and to relate the optimal tax rates with those meaningful economic expressions. He also shows that the assumption that preferences are homogeneous, so that agents have the same preferences, is actually not necessary for the results, at least for the high income tax rates. Finally, he shows that, the optimal tax schedule can be estimated using empirical income distributions. So the paper is starting with taxation of high incomes. So basically, the author is kind of fixing one particular earnings level and considering all the individuals who have an earning level equal or above this earning level. So it's a two-good model, and we have taxpayers which maximize a well-defined utility function, which is given here. C is consumption, Z is earnings, and so an individual has a strictly increasing utility of consumption and strictly decreasing utility of earnings. Because for earnings, you would have to would have to choose a strictly positive working time. As in Merle's, the taxpayers have different skill or ability, and this is implicitly captured in U. So this is not made explicitly here, as it was in the Merle's paper. So taxpayers have a budget constraint, which is given by this expression here. So consumption must be equal to earnings times kind of the net that you have after, or it's like consumption must be equal to net earnings. So earnings accounted for the tax rate that you would need to pay, in addition to this R parameter, and this is non-labor income. So you can think of this as kind of income which is already there. Okay, so you don't have to work for it. You can refer to this income even if you do not have any labor supply. And in addition, this expression 1 minus tau this can be actually interpreted as the price of leisure. Yeah. So the higher 1 minus tau is, the kind of more expensive it is to consume leisure, so to not work basically. So what you then can derive is a first order condition. So you solve the optimization problem of the individuals, and you end up with this first order condition here, which yields a Marshallian earnings supply function. So supply function from utility maximization, which depends on the cost, like which depends on the tax parameter and on the non-labor income which you have. In addition, we will consider the notation of a Hicksian demand, so a Hicksian earnings supply, which then is derived by minimizing the costs that you have needed so in order to reach a fixed utility level U, given kind of the labor income, non-labor income, and the tax rate. So this is the Hicksian earnings supply. Then what will be kind of used throughout the paper are the following elasticities. So here we have the uncompensated elasticity, and on the right-hand side we have the compensated elasticity of labor supply. So the uncompensated labor supply would be a change, like a relative change in labor supply if the price of leisure is increasing, and the same holds for the compensated elasticity supply, in that it is the compensated change in labor supply if the price of leisure is increasing, but we are holding constant the utility that we want to arrive. Yeah. So kind of if you want a really simple explanation, this compensated elasticity basically gives you a notion on how the relative value or the relative evaluation of leisure and consumption changes if the price of leisure is changing, holding fixed income effects. That's the idea of a compensated change. Then we have a third kind of elasticity, which is capturing the income effects, and those are changes in your real income. So changes in your behavior due to changes in your real income, because the price of leisure is increasing. Finally, what you maybe have seen also in your introductory micro course is a Slutsky equation, which is basically linking all the different elasticities with each other. Yeah, so the compensated elasticity is equal to the uncompensated elasticity minus the income effect. So the government is deciding about a constant linear rate tau above some fixed level of earnings or income, Z upper bar here. Without loss of generality, we have so we consider a population which, with all the individuals who have a higher income than Z upper bar, and we normalize the mass of this population to 1. And with this density here, so H of Z, we denote the density of the earning distribution at the optimum tax regime. Yeah, because it's endogenous. So depending on the tax regime, of course, earnings differ because people react to changes in the taxes, and therefore also the density of earning changes. What we will do is we will consider a marginal increase of a tax rate given by d tau here for all incomes above the upper bar. And this increase actually has two effects on the tax revenue. So first, there is a mechanical effect in that it basically increases the tax revenue if taxpayers do not change their behavior. So this is kind of a hypothetical situation where you could think of if all the taxpayers would simply pay the additional tax due to the tax increase, then the mechanical effect would be, of course, strictly positive, and the tax revenue would increase basically. But there's also behavioral response because, so this was the mechanical effect, there is obviously also a behavioral response because the relative price of leisure changes, of course, once the marginal tax rate or the tax rate is increasing. So therefore, we have a second effect, which is the behavioral response. And yeah, then kind of the taxpayer is changing his behavior, so he's changing his earning supply. And as an effect, the tax revenue could decrease because this individual is choosing to work less, which basically means that less taxes are paid. And we can formalize this. So the mechanical effect is denoted by capital M and is simply given by Zm minus Z upper bar times the change in the tax rate. And Zm is basically denoting the mean income above Z upper bar. Okay, and then this M expression is basically summing up the mechanical effect of all individuals when we are increasing the tax rate. Then we have a behavioral response, which is basically summing up um, the distortion effects due to an increase in tax rate, since leisure becomes relatively more expensive than consumption. Therefore, this B parameter here, so the B expression here, is basically summing up all the distortion effects that we have. We will need some additional notation, which unfortunately I cannot, due to the sake of time, I cannot go too much into details of it. So if you're interested in like getting more information about it, look into the paper itself. So we will need kind of a notion of social utility when we are thinking about high income optimal tax rates. And this is introduced in the paper by this G upper bar here. And this is the ratio of social marginal utility for top bracket taxpayer. So the ratio of the social marginal utility, so the marginal utility that the government derives from individuals with high income relative to the marginal value of public funds for the government. So relative to the value it has to expenditures that it's conducting or relative to the value it has with respect to other individuals which are not in the top bracket. So the takeaway is that the smaller G upper bar is, the less the government is actually caring about individuals with a high income because it does not value the marginal consumption of high incomes. Yes, so if you think about the Merle's paper that I showed you before, we also had this welfare function. I think it was capital G. And you can think that a strictly or strongly concave capital G function would correspond to a smaller value of G upper bar here. So given this notation, the optimal tax rate is implicitly given by the following first order condition or equation here, such that when we plug in all the values and we arrange, we kind of come to an expression which is quite simple here. So it can be easily interpreted. And this is defining the optimal not the marginal tax rate because it's constant, but it's the optimal tax rate for high incomes. And yeah, let's go into the details of what we basically see here. So we can make several observations here. So first of all, this formula that you see here, it can be applied to situations where agents have heterogeneous preferences because for the derivation of this expression, at no point the author used the assumption that preferences are homogeneous. Yes, so even if you would have a model with agents who have different preferences for the consumption goods and different preferences for leisure in different effort costs, for instance, to work, then you still would get this result here. So that's quite interesting because it generalizes. The second is that the optimal tax rate is decreasing in this ratio G upper bar, and it is also decreasing in the elasticities. Yeah, so the higher this the higher G upper bar is here, the higher you basically choose, like the higher is the tax rate for individuals with high income brackets. And at the same time, if the elasticities are increasing here, so you can think of elasticities always representing some kind of distortion. So if you have high distortion, it means that the impact on your tax revenue will be relatively large. Therefore, if the distortion kind of increases due to an increase in the elasticities, the tax rate should decrease, because then you basically lose. So due to the increase, you lose tax revenue because individuals work less and pay less taxes. Yep, so this is the idea here. The next thing is that the optimal tax rate is increasing in this ratio of the mean income above the upper bar and the value of the upper bar. And the interesting thing here is that if this income distribution is bounded above, so it's not infinity, but you have some kind of a maximum value for the distribution of earnings. And if you consider this Z upper bar here being very close to the upper boundary of the support, then actually the ratio will be close to 1. Yeah, because if the mean will not be so much different than the boundary that you consider here, the closer you get to the upper boundary. But if this ratio is close to 1, then what we have is basically that this expression here, we'll choose a different color, so this expression here will be 1, and hence the term in the bracket will be close to 0, and the right-hand side will be equal to 0. And the only way that we can basically solve this equation when the right-hand side is equal to 0 is by having a tau equal to 0. Yeah, and this is kind of a statement that if you consider really the individuals with the highest income, then tau should be equal to 0 in an optimum tax rate, which is kind of reminiscent of this result that we also had in papers building on Merlis, that the marginal tax rate should be close to 0 for very high incomes. Yeah, and the takeaway is that if you consider high incomes, the tax rate is linear, so at least for in this model, and it depends negatively on the thinness of right tail of the income distribution. Yep. So the more the more individuals you have on the right tail of income distribution, which means that the more individuals you have with a high income, the less should be the tax rate, lower should be the tax rate. What Saez is doing in the next step is that he's using empirical earnings distributions to make some statements about things which have been found or identified in the previous literature. So what he, for instance, finds is that the zero top result, so the result that the marginal tax rate should be close to 0 for very high incomes, this holds only for agents with the highest income. Yeah, so almost the highest income or the highest income. So it's a very, very local result, and it does not give you any information about individuals which are close, kind of a little bit far away from the upper boundary of the support of the highest income. Then if the elasticities are not very high, so distortional effects aren't that strong, then the tax rates for the high income agents are fairly high. Yeah, and this is compared to the simulations in the Merlis paper, where we had fairly low rates of marginal tax rates compared to the Saez paper. And one other thing that he finds is that optimal tax rates are very sensitive to compensated elasticities. So changing the parameter which measures the compensated elasticities changes the structure of the optimal tax schedule. And I also put you some pictures which I took from the paper. And on the left-hand side here, you can see, on the y-axis, you see this coefficient, which is the difference, so the ratio between the mean income above Z upper bar and Z upper bar. And then we're varying the Z upper bar here. And what you can see is that even if we get close to very high incomes, this ratio is still above 2. Okay, so it's not far away from being 1, which basically was a situation where you would say that the tax rate should be equal to 0. And the same thing holds for 1993. So this is a different year here. And yes, as you can see, the statement here is that even if we go to very high income levels, so here we're even going to, what is it? This is 10,000 K. I think 10 K is 1,000. So this is $10 million. So even if you use data on like earnings distributions and you're considering very high incomes, this ratio is still above or close to 2. So we are far away from a situation where individuals are basically having a coefficient equal to 1, such that the tax rate should be equal to 0. Yeah, and this is kind of a way to show this. And in addition, in table 1, this is also taken from the paper, he is basically varying the elasticities. He's also varying the shapes of the income distribution. So he's using a Pareto distribution, which has 2 shape parameters, I think, and he's basically varying all those things and yeah, showing how the optimal tax rate changes for high income earners. And what you can basically see is that fixing kind of, just as one example, fixing the compensated elasticity at some level, everything else as well. So let's say we are basically comparing this value here with this value here, and then with this value here, what you can see is that as we are changing the uncompensated elasticity, so we're increasing it, which means the distortional effects get stronger and stronger, the optimal tax rate would decrease, yeah, because we have distortional effects which are increasing if the uncompensated elasticity is increasing. Yeah, and this is reflected here in the table. Yeah, and also other things which you can basically see is that if we fix everything but the compensated elasticity, what we for instance have is that yeah, if we increase the compensated elasticity, also the tax rate is decreasing because of distortional effects that we are considering. In addition, if we increase G, so we care more about the social marginal utility of high income individuals, what you can basically see is that the marginal tax rates are decreasing, or the tax rates are decreasing for individuals with the highest income. Yeah, so everything which we find here is kind of intuitive and reflecting what we found in the formula, which is obvious because the formula is used to estimate those things. Okay, so what we did so far was that we only talked about high income tax rates, but of course this is only one part of the paper distribution of the income distribution. So then what the paper does is that it proceeds to the analysis for any income level. And it's basically using the model in Merlis, but it is, as I said before, able to give kind of economic intuitions behind the first order conditions which characterize the optimal tax schedule. So we will need some new notation here for the section. So we still have a utility function representing the preferences. C is consumption, and now L is labor supply. Now we have an explicit way of modeling heterogeneity with respect to skill, in that, as in the Merlis paper, we consider a skill level N, and from the perspective of the policymaker or the government, N is distributed on an interval, and the earnings of an agent is a function, earnings of an individual is a function of his skill times the labor that he's supplying. Population is normalized to 1. This is without loss of generality. And with Cn, Zn, and Un, we denote optimal consumption, earning, and utility levels for an agent. As in the Merlis paper, what we assume here is that the government can only observe income, so it's not able to observe the ability, and it can only set taxes according to the income. Yeah. So then, given a tax schedule, somehow given by the function t, the agent faces the following constraint. So his consumption is equal to his earnings minus the payment that he has to conduct, so the tax that he has to pay depending on his earnings. So the government is maximizing a social welfare function, which is given by this here. So as in the Merlis paper, this G function is measuring kind of um, it's kind of a measure for the goal of the government. So if G is a very strict concave function, then the marginal utility for individuals with high income are very low. So it cares more about poor people than about rich people. So this is a way to incorporate different goals into the objective function of the government. We have a resource constraint, which is basically saying that aggregate consumption or aggregate demand for the consumption good should be weekly smaller than aggregate earnings minus the resources that the government needs because it needs to invest into a street or something like this. Yeah? So it needs capital E, and this will be subtracted from the total earnings in the economy. In addition, there will be another constraint, which is an incentive compatibility constraint, which basically says that individuals indeed maximize their utility, and it's given by this expression here. And you can get this expression, it's not so difficult, by considering that you have a constraint, and if you plug in the constraint into your utility function, so it's given here, and consider that z is equal to n times L, and then you maximize the utility function where you only have L as an endogenous variable, you come to this first order condition here. This is also a constraint because we want individuals to be rational and to maximize their utility. So then in the paper, we have proposition 1, which yields a description of the optimal marginal tax rate for all income levels. And in a very compact way, it's written like this. I will not go into the details of what those expressions you mean, because this is also too complicated to do it in this short time. But I will go into the meanings of what kind of led to this particular form of the implicit equation which defines the optimal marginal tax rate. So there are basically three factors which affect the optimal marginal tax rate. So the first one is the shape of the income distribution, which is endogenous, of course, to the shape of the income distribution is endogenous to the tax schedule because the tax schedule has an impact on the income that individuals are getting. So the second is substitution and income effects, so distortions basically. And the third is marginal welfare weights. So what is actually the goal of the government also impacts the optimal marginal tax rate, obviously. So let's talk about the shape of the income distribution. So what we can say is that high marginal tax rates at income levels where the density of taxpayers is low compared to the number of taxpayers with higher income. So basically this says that if you are in a part of the income distribution where the fraction of people who get affected by an increase in marginal tax rate is very low relative to everybody who has a higher income, then you should choose a higher marginal tax rate for those individuals. And this holds especially at the bottom of the income distribution. And what is the intuition here? So obviously, for the individuals who are exactly at this income level where you're increasing the marginal tax revenue, you have a negative distortion effect in that leisure becomes relatively more. So if you increase the tax, leisure becomes more expensive than consumption of the good, and therefore you have a loss in revenue because individuals at this exact point where you change the marginal revenue are changing their behavior. But on the other hand, there's a positive effect. If you increase the marginal tax revenue at a particular point, it leads to higher tax payments by all other individuals who have a higher income than the individuals which are affected by the marginal tax increase. And this means that we have an increase in tax revenue because they're simply paying more taxes without them, without the relative prices for them being changed, because there is no impact on the marginal tax rate for those individuals. Okay, so for them, it's just a shift in the tax payment and not a change in relative prices. So this is why you should consider that high taxes for the lowest kind of individuals with the lowest income level in this model. Then we have, of course, substitution and income effects. So an increase in the marginal tax rate at a particular level of income has two effects. So I described it a little bit just a second ago. So you have a distortion effect on agents at this income because for those agents, leisure becomes relatively cheaper. Yes, relatively cheaper, of course. Yeah, I think I said it wrong before. So if you increase the tax rate, leisure, of course, becomes relatively cheaper, and this will have a negative effect on tax revenue because individuals will choose to work less. They will choose less labor supply. Um, in addition, it will have an income effect on all agents above Z. Yeah, so this will induce those agents to increase labor supply because they're simply lost real wage, so the real wage of them decreased, but they basically try to come back to a utility level which is equivalent to what they had before, and they choose kind of a strictly they increase their labor supply in order to increase their real wage, which has a positive effect on tax revenue because they simply increase their earnings, and an increase in earnings means that also the tax revenue increases. So this is the trade-off that you have when you increase the marginal tax rate at a particular point. Then the final point is with respect to social marginal welfare weights. So if, for instance, the goal of a government is redistribution, which means that if its social marginal utility is low for high incomes, then it should choose a progressive tax schedule. Okay, so depending on how this capital G function is looking like, whether it's convex, it's linear, or whether it's concave, the goals of the government are changing. And in the same way, the optimal tax schedule is changing depending on those goals. So what the paper then does is that it proceeds to calibrate the parameters related to everything which is important. So the income distribution, the elasticities, and the redistributive tastes of the government. So what's the goal of the government with respect to this G function? It's using two types of preferences to abstract from income effects. And by doing so, it is considering one type of preference with income effects and one without income effects. And you can see in the paper exactly how the utility functions in the cases are looking like. Also, by kind of approximating the goal of the government or the redistributive taste, it's considering two types of social welfare functions. So the first one is a utilitarian, and the second one is a Rawlsian. In a utilitarian, the government is simply maximizing the sum of indirect utility functions, and it's attaching weights to the individuals which are proportional to the marginal utility that the individuals get, or the utility level that the individuals get. So this is a utilitarian way, which is less like it's less about redistribution than the Rawlsian social welfare function, because in the extreme case of the Rawlsian social welfare function, you only care about the individual with the lowest income in the society. So this is basically, trying to approximate two different goals of the government. Then, in addition to consider different magnitudes of distortions, he also considers different values for the elasticities. So this is also taken from the paper. So The changes here are with respect to the compensated elasticity, which you can see here and here. So in each picture, you have a change in compensated elasticity, an increase. We have changes with respect to the welfare criterion here, and we have changes with respect to utility type 1 and utility type 2. And let me just look into the paper because I forgot about which one of them is the one without income effects. Yes, so utility type 1 is the utility function without income effects, and utility type 2 is the one with income effects. So when we consider utility type 1, we can basically abstract from income effects and only look on changes with respect to distortion of the other effects that we have. So what can we see here? So obviously, if we fix one of the pictures here, the only thing which is changing here is the elasticity, the compensated elasticity. And what you can clearly see is that if the compensated elasticity is increasing, and this holds for all the pictures that we see here, the marginal tax rates are decreasing. And the reason is simple, because the higher the compensated elasticity, the higher is the distortion, so the change behavior of individuals due to an increase in the marginal tax rate. And therefore, the impact on tax revenue will be quite strong if we increase the marginal tax rate. Another interesting thing is that when we consider the changes in the utility type, so when we are holding everything else fixed, so if we compare those two pictures with each other, the only thing that we are changing is the utility type. So we are going from a situation with income, so without income effect, to a situation with income effect. What you can see is that the marginal tax rate is increasing if we consider a situation with an income effect. And the reason here is simply because if we have an income effect, we increase the marginal tax rate at a particular point, we have a benefit due to an income effect on everybody who has a higher income than the individuals who are affected by the increase in the marginal tax revenue, since they increase their labor supply. And this means that we can increase the marginal tax rate, or we increase the marginal tax rate to benefit from this effect. At the same time, what you can see is that when we change from the utilitarian criterion to a Rawlsian criterion, so if we care more about individuals with low income, or when we care most about the individual with the lowest income, what you can see is that there are not so many changes with respect to the marginal tax rate in kind of in the high income brackets, but there is a big change with respect to the change here with respect to the marginal tax rate for individuals who have the lowest income. And the reason is simply that here you want to increase the tax revenue without causing much distortion in order to redistribute it to individuals with the lowest possible income. Yeah, so that's the idea that you have here when you're changing from the utilitarian criterion to the Rawlsian criterion. And the same also holds for the situation where you have a utility type 2 with income effects. Okay, so the picture actually nicely summarize kind of the some intuitive ideas that one would have if one would think about changes in the tax schedule. Which brings me to the conclusion. The paper, so the Saez paper used economic theory to link optimal marginal tax rates to expressions which have a nice economic intuition and can be estimated. So in particular, those were shape parameters of the distribution, elasticities, so compensated and uncompensated elasticities, the income effect. And due to the Slutsky equation, actually, you can link the you can link the compensated elasticity to the uncompensated and the income effect, both of which are yeah, you can estimate them. So you can estimate everything which is in those formulas, which is nice for application and empirical work. And compared to the Merlis paper, this paper can actually give clear answers on how an optimum tax schedule should look like. So whether it should be progressive, should be linear, or whatever, depending on the goal of the policymakers. Yeah, and this is kind of a big value for policymakers because it gives clear answers to particular situations, which we did not have in the Merlis paper. So this is everything with respect to this week's exercise session. If you have questions, please let me know. You can write me an email. I will upload the slides here on Moodle. I will also upload the two papers. I think I've already done this. So I will upload the papers on Moodle, and I'll also upload a version of the slides where I scribbled something on them on Moodle, so you can somehow also have this version. Because I think I corrected a mistake at some point. So yeah, you can have both versions. Good. Then see you next week.